Welcome back to part 5 of lesson 8. So we're going to discuss here now trigonometric ratios. So when are we going to use trigonometric ratios? When instead of a given sides, okay, we have now a given angle and a side. So let's take a look what are these trigonometric ratios. So these are the basic trigonometric ratios. So before we start, let's familiarize with the elements, okay, of the ratio. So again, trigonometric ratios are found in right triangles. Okay, so we're given an angle, or angle is sometimes denoted by theta or denoted by capital letters. Okay, English alphabet. So opposite of the angle, we have the opposite side. Okay, then at the sides, okay, of course we know that the longer side or the longest side, we have the hypotenuse. Okay, so we can actually denote this one as small letter C and the opposite as small letter A, or let's just have O and this is H. Okay, for our illustration, O and H, opposite, hypotenuse. Then at the side, the shorter side, okay, so adjacent to the angle. So when we say adjacent, it's neighbor. Okay, it's like neighboring side, or it's closer to the angle. So we have the adjacent side. Let's denote this one as A. Okay, so we have O, H, and A. So I hope that you are familiar with this, the SOHCAHTOA. Okay, and we also have the CHOSHCAHTOA. Okay, the reciprocal. Okay, we have the reciprocal ratios of SOHCAHTOA. So for sine is actually opposite over hypotenuse. Sine is opposite over hypotenuse. So we're going to have this here. If there's a value here, so the value of the opposite over the value of the hypotenuse h. Okay. For cosine, so cosine is simply adjacent over hypotenuse. So it's the opposite of sine. It's kind of the opposite of sine. So if sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. Then we have tangent of the angle. Okay, so the tangent of the angle is just the ratio of the opposite and adjacent, or opposite over the adjacent. That's why it's TOA. Okay. Then we have the CHOSHCAHTOA. You don't need to memorize this one. You just need to remember that cosecant is the reciprocal of sine. Secant, or the secant, sorry, it's read as secant. Secant, which is the reciprocal of cosine, and cotangent, which is the reciprocal of tangent. So again, reciprocal, we have the what do we call this? It's the reverse. Okay, reverse of the ratios. So we have now hypotenuse over opposite, for cosecant. For secant, we have hypotenuse over adjacent, and for cotangent, we have the adjacent over opposite. Let's have an example. So determine all the trigonometric ratios of the given triangle. So our angle here is alpha. Okay, so we have the angle here. Okay, so we have sine. First, we need to find sine alpha. And sine alpha, again, sine is which is opposite over hypotenuse. And we know that our opposite is 8 here. This is our O. Okay, and 17 will be our H, and 15 will be our A. Okay, so we have opposite 8 over hypotenuse 17. Okay, so that's our sine function. let's have the cosine function. The cosine function is cosine alpha. Okay, so cosine alpha, it's adjacent. So ka, remember it's SOHCAHTOA. I just read it. SOHCAHTOA. So cosine, we have the adjacent. Our adjacent is 15 over the hypotenuse, which is 70. Okay, and then we have the tangent. Our tangent alpha. So by the way, we are using the exact values. When we say exact values, it's in fractional form, or not non-decimal form. Okay, so we're not using decimals here. So just stay put with the fraction. We need the exact values. So for tangent, we have TOA. TOA meaning opposite over adjacent. So opposite is 8 over adjacent, which is 15. Okay, then we have the reciprocal functions. So since we are being asked to get all trigonometric ratios, so we have the reciprocal ratios or functions. Okay, so we have cosecant alpha. So we just use this for 17 over 8. Okay, then we have secant alpha, which is 17 over 15. And we have cotangent alpha, which is 15 over 8. Okay, so that's the answer. Let's have example number 2. We have to find the missing element. So looking at the given, we have a right triangle here. So we're given an angle, so 68 degrees. And we are asked to find this line segment here, or this side, JJ. So let's just say this is X for simplification. Okay, so if we try to look at this, so opposite of the 90 degrees, we have 11.4. So we are sure that this is the hypotenuse, and X is our opposite side. Okay, so using our knowledge on the ratios, try to think of a ratio which uses opposite and hypotenuse. So let's go back to the basic SOHCAHTOA. So we have SOHCAHTOA. So from this, it's very obvious that we have SO, which is sine equals opposite over hypotenuse, which uses these two elements. So we'll be using sine. Okay, so we have sine of 68 degrees equals opposite is a node, it's X. That is actually the thing that we're looking for. Okay, then over our hypotenuse is 11.4. Okay, so from this we can cross multiply. 11.4 sine of 68 degrees equals X. And if we try to use our calculator, so this is our calculator. Okay, so here is our calculator. So let's try to solve again. Try to change the setting of the calculator. It should be in degree mode. So just click shift, then set upper mode. Then we have here tray, so our degree mode. So we have 11.4 sine of 68. Close parenthesis and this gives us 10.57. We have 10.57. We have 10.57. So x is 10.57. Okay, and take note. Let's just take this one. Okay, so take note that we have a unit here, hence we will use the unit meters also. And this is our final answer. So the missing side is 10.57. Let's have another example. Example number 2 for trigonometric ratios. So again, we have the angle here 57 degrees and we have 9.8. Okay, so determining the given, we have the opposite. Okay, again, opposite side is always opposite of the given angle. So 9.8 is our opposite. Okay, so and we're asked to find, so this is actually adjacent. We're asked to find the adjacent. So AB, the length of AB is the adjacent, length of the adjacent side of the right triangle. So we're not given with hypotenuse. Okay, so we have the given O and A. So from SOHCAHTOA, it's very obvious it's TOA. So TOA is tangent, okay, of our angle. Given angle is 57 degrees. So O is 9.8. Okay, over, then we have what is asked is AB. So let's just say this is our X. Okay, so we are asked to find X. Then cross multiplication, we will have X equals 9.8 over tangent of 57 degrees. Oh wait, it's not clear. I'll put the calculator away. Okay, so it's here. Okay, so let's try to solve using our calculator. We have 9.8 over, again, check if it's in degree form, so it's in degree mode, okay, or form, so it's okay already. So we have tangent, so tangent of 57 close parenthesis, and this will give us 6.36. Okay, so we have 6.36. I'll just move it here. Okay, 6.36. Okay, so we have our answer as 6.36. Okay, of course, I forgot. I forgot to put in our previous example. Do not forget the unit also, since there is an indicated unit millimeter. So, okay, so that's example number 2. Let's have example number 3 for trigonometric ratios. So what if we are missing an angle? Okay, so again, it's not anymore the side but the angle. Okay, so again, using our ratios, so our 34.2, so given, we have given here 34.2 meters is actually our opposite. So this is opposite. And we have here, so this 38.7 is actually the hypotenuse. Because we have HO, so we can actually use from our SOHCAHTOA, we can use SO, which is sine. So we have sine theta equals opposite, which is 34.2, sorry, 34.2 over, which is 38.7. Okay, so how are we going to go about it? So in finding the angle, we're going to find the inverse function of the ratio, or the inverse of the ratio. So what's the inverse? We're going to use arc sine. Okay, so how do we use arc sine? So theta becomes arc sine. Okay, so arc sine of whatever is here. Okay, whatever is here. So we're right. Just right. 34.2 over 38.7. Okay, I'll just move the calculator a little. Okay, so it's here. Okay, so what is 34.2 over 38.7? So it's the ratio, it's still O and H. So how about arc sine? So what is this arc sine here? So in your calculator, where's the calculator here? In your calculator, try to find the, sorry, you're going to look for the symbol which is sine to the power of -1. Again, you're going to look for a symbol in your calculator which is indicating a sine to the power of -1. Okay, so it's actually above the ratios or the functions. Okay, so we have sine here, cosine here, and tangent here. So we have sine to the power of -1 here. So simply click shift. Okay, shift, then click sine. Okay, and you will have sine with the superscript -1. This is actually arc sine. This is actually a notation of arc sine also. Then input. Okay, input your ratio. We have 34.2 over 38.7. Then close parentheses, then put equals. So we have 62.09. Okay, so this 62.09 is actually our angle. Okay, 62.09. So we will have theta being 62.09, and don't forget the unit, which is degrees. Okay, so answer here is 62.09 degrees. Let's have the last example. So again, we're looking for the angle here. It's the angle alpha. So given, we have the given here, which is the opposite of alpha, and we have also the adjacent of alpha. Okay, so I'm sure that this is adjacent because it's not the opposite of the 90-degree angle, so it's not the hypotenuse. Okay, so obviously we're going to use tangent here. So we have tangent alpha equals, so it's TOA opposite, so 17.1 over 15.6. Okay, then again, to find the angle alpha, we're going to use arctan. Okay, so we can actually just write tan. So we have -1. Okay, so para it's the same with the calculator na lang. Okay, so we have 17.1, just copy 15.6. Okay, then using your calculators, clear. Okay, I need to clear this. So we have arctan, so shift click tan, so you will have this 17.1 over 15.6. Okay, then close parentheses, click equals. We have 47.626. So there is 6 to 6 here, so this becomes 63. Round off to 63. So we have alpha 47.63. So alpha is 47.63 again. 47.63. It's an angle, so do not forget the degree symbol. So we can put here 47.63 degrees. So that's the answer.